I think we're about ready to get started. Let me introduce our speaker, who's been invited by the library and the Olmsted Society. I encourage those folks who are from the area and are interested in promoting the ideas of Frederick Olmsted to support the Olmsted Society as a member. You can go to our website and find information there about membership. Steve Pescitelli, the pronunciation? Steve Pescitelli has been kind enough to speak with us. He's a stream and river ecology expert from the Department of Natural Resources. And others in the community who work along the river have highly recommended Steve as someone intimately familiar with the quality of the displays and things that have changed since the state of Illinois has begun removing dams. So I'm very interested to hear your talk, and thank you for coming tonight.
Since this is being filmed for Riverside TV, they're asking that you all take your phones and put them on silence, please.
I should do that then.
Working, so in case you
That's okay. Can everybody hear me okay? Okay. Well, thanks a lot. It's a pleasure to be here. I've worked in this area for about 20 years now, and spent a lot of hours on this section of river here. It's one of my favorite sections of river, and you probably think I say that to everybody. But it's true, because this river is constantly surprising me, and it's got a great story behind it. As you all know, probably better than I, at one point nobody wanted to go near the river, that it was very degraded, and so it has improved a lot, and it continues to improve. It actually even surprised me in our last survey. So I want to share that with you, as well as talk about some of the activity we've been doing to try and improve it further by removing some of the obstacles to fish migration and these dams that cause water quality and so forth. Now, I'd love to take your questions, but I think I'll wait until the end, since we're filming this, and I'll be glad to field any questions after I get through this. I'll take about a half hour, maybe a little less. So anyway, that's what I'm going to talk about tonight. The changes in the quality of the Des Plaines River, and how the dams have helped move that along, and hopefully move it along even further in the future. So this is kind of the agenda for tonight. I want to talk a little bit about our sampling program, because that's at the base of what I'm going to talk about, and how we use fish to determine stream quality, and results of our last survey, which was conducted in 2013. It's the 5th survey we've done in the entire Des Plaines River watershed, and review the trends since 1983. There was a major study done in 1983. And then we'll move on to talk about the results of dam removal studies at the Hoffman Dam itself, and some other areas around the state where we've been actively removing dams and able to sample the fish and document the benefits. And then we'll talk about some of the future dam removals, ones that occurred in 2014 and planned for 2015, and then talk a little bit about the importance of maintaining connections in the river system, so that the fish can come back to the Des Plaines River, those that have been lost. So, like I said, I've been working in northeastern Illinois for 20 years. This is my area of responsibility here. The watersheds of northeastern Illinois includes these watersheds: the Fox, Des Plaines, Chicago, Kankakee. And actually, I like to say I have some of the best and some of the worst streams in the state, because as you move closer to Chicago, and the Chicago waterway system are very degraded, not very high quality, but when you get out to the Fox and the Kankakee, they're some of the best streams in the state. And it's a unique area due to the more recent glaciation than a lot of parts of the state. A lot of different habitats, from little creeks that are very low gradient to higher gradient rocky streams like this, small rivers to larger streams. So a lot of different habitats, which means we have a lot of habitat diversity and a lot of diversity of fish species and different aquatic insects and mussels. So a very diverse assemblage of critters that survive and thrive in the streams. So one of the things that I spend a lot of time doing is sampling fish, because by looking at what fish are there and what proportions, we can tell a lot about the quality of the stream. So we do that in a variety of different ways. I spent a lot of hours boat electrofishing right out here on this river, probably about every year since 1996, due to the involvement of the Hoffman Dam river rats in managing the fishery and helping us get the dam out. So we've been here a lot, and on smaller streams we use some other types of equipment that basically delivers a small electric charge to the water, stuns the fish. We pick them up, weigh them and measure them, identify them, and put them back, and then use that data to evaluate the stream quality. This is a map of all the sites that we've studied, that we've sampled in northeastern Illinois over the last 20 years. There's basically two major programs, and these didn't turn out very well, but these little green dots are the Basin survey programs, and we do sample every major basin in the state every 5 years, trying to keep track of the quality. And then we have some other programs where we go in and do some more fine-tuned sampling on the smaller streams, and then of course sport fish management and evaluating projects. So anyway, what I'm going to talk about today is this Basin survey program, and I'll start with the results from our 2013 Basin survey. And all these little dots and lines are all the stations that we did in 2013. I'm going to focus primarily on the main stem of the Des Plaines River. We did a lot of the tributaries, but tonight I'm going to talk about the main stem primarily. So this is kind of a overall summary of what we found. We sampled 34 stations, almost 20,000 fish we collected from 15 different families, and that's 70 species. So that's a pretty high tally of species. This time was the first time we actually got 2 species that are on our threatened and endangered list, an Iowa darter and a banded killifish. And then of course, the non-native species, the species that shouldn't be here. Round goby has actually come down from Lake Michigan and back up Des Plaines River, and various other things. Common carp have been here for years, and so have goldfish. This one is not very abundant, but it's starting to show up here and there. Very strange loach fish. Really strange barbels. You wonder whether it's a fish or not. I don't think that's why they named it that, but anyway, no Asian carp. I know people are very interested in that. It's been in the news, so we didn't find any Asian carp. Here's a few of the species that we found. There's a top minnow and a mud minnow and stone roller and darters. These are all really small fish that people aren't familiar with because you can't see them very readily. These are the fish you're probably more familiar with, all in Des Plaines River. Rock bass have come on actually quite well. Bluegill, smallmouth bass, we're getting more and more of those. We got a lot of them just last year in 2014. An orange spotted sunfish, which is throughout the river. Largemouth bass, of course, are about everywhere, as are black crappie. And this is a long-ear sunfish, which is a really beautiful fish that only occurs in the very lower part of the Des Plaines. More sport fish. If any of you spend any time fishing, I'm sure you've run into these species. The pike, channel cat, walleye, and sauger, which we actually stock in the river. We have had a stocking program since 2000, and they've done very well in the river. And this guy, long-nosed gar, a very ancient fish that's been around since the dinosaurs, who actually just showed up in recent years, along with a few other species we'll talk about later. So this is the kind of data that we get. What I'm showing you here are the 15 top species, and that tells us a little bit about what's going on. You notice there's a T by some of these, and those are the tolerant species, those species that are the hardiest, and they're everywhere. They can take pollution and habitat degradation. So there's a few of them in there, but they're not the most abundant, and I'll talk about that. That's a change from 2008, and I'll show you a slide about that in a few minutes. But this is one way we look at what are the top species, what's the composition, who's dominant. But the way we really evaluate stream qualities, we use this index of biotic integrity. So we take this fish data that we've gotten by our various techniques, plug it into this index, and this is calibrated to the area of the state and the size of the stream, and it looks at all the how many different species groups there are, and there's these functional groups, insectivores, and how many tolerant species there are. And I'll talk a little bit more about these two groups later. But the thing to keep in mind is basically it ranges from 0 to 60, so the higher the better. And you really need a change of greater than 10 to be biologically meaningful. I mean, there is some natural variation in this index, so keep that in mind as we go through the data. So here's the results from the 2012 or 2013 Des Plaines Basin survey on the main stem. And so what we have here is this is the index of biotic integrity from 0 to 60 on this axis. And on this axis are the stations we sampled all the way from Wadsworth, way up in the watershed, down to I-55 Bridge. So that's below Brandon Lock and Dam. So you can see it's moderate quality, kind of goes down a little bit as you move downstream. And then there's these little bumps where you see a little better quality, and those are the higher gradient areas. This is G33, G39 is Riverside, and right above the former dam at Salt Creek. A little higher gradient, a little better flow, keeps the sediment moving. We tend to have a little better quality. They tend to be a little less vulnerable to sedimentation and degradation. So how does that relate to anything? EPA has a criteria of 41 IBI. It's one of the criteria they use to determine if a stream is meeting the minimum biological standard. They call it a biological use. So we're still a little bit below that. But we are moving in the right direction. And I'll show you some data from previous surveys to kind of give you a feeling for that. The first basin survey for Des Plaines was done in 1983, and they did 11 stations on the main stem. There's kind of a gap between then and now, as there wasn't a biologist in this area. And when I got hired in '94, took us a few years, but that was the first survey that was done since then in '97. So we've tried to keep a few more stations and to get an idea of how things changed over time. And then I'll do some comparisons using all this data, but also show you some comparisons using stations that were only collected in every single survey. So we can keep things steady, the locations, and kind of do some really more robust comparisons. So moving forward, here's kind of using all the data. This is the one I showed you before from 2013. The IBI, there's a mean of 30. You look back, 1983, much lower. We had a mean of 15 for the IBI. So you remember that's more than 10, so that's biologically meaningful, and I don't think you need that to tell you that it's improved. So that's good news. I mean, the Clean Water Act in 1972 takes a while for things to clean up, but the treatment plants are doing a better job. So I think that's probably, water quality is probably most important factor here. Now this one, a little confusing, but we're getting into that, making the comparisons at those stations that were sampled in every single survey. So you can see the red is 1983, and then the colors correspond to the different years. So there's a pretty big bump after 83 to 97. And and then a lot of these stations showed continual improvement over the years. Another way to look at this is take the mean for each year for all those stations. So this is the mean of all those stations for each year. You can see there is a pretty good improvement in 1997 and about the same in 2003, but the last two surveys we've seen a slight improvement. So that's good news. I mean, I'm not sure if the water quality is getting better, and we hope that the dam removal maybe had something to do with this. We can't say for sure. But I showed you that top 15 list for 2013. And these ones that are marked in yellow are those tolerant species that I mentioned. So in 2008, you can see that they were actually dominant in the survey. There was, 3 of them in the top 5? Well, now we have these species that they're not exactly intolerant, but they're kind of, we call them neutral species. But they now dominate the population, and the tolerant species have now become less dominant or less abundant. So that explains that change between 2008 and 2013. So it's good news. I mean, the river continues to improve. This is a little different way of looking at it. Here's these tolerant species, the percent of the collection which was considered tolerant in each year that we did a collection. So you can see that line on the graph is going down, kind of like my stock portfolio. So, but the neutral species are going up. Now there is a group of species that are intolerant. Those are the first to go when there's a problem with pollution or habitat. So there was none in 1983. So we've kind of seen a few more, in the first few surveys, but that's kind of flattening out. So in order to get a really good IBI score, we're going to have to somehow get those up. And those species are kind of showing up very slowly. So anyway, this is kind of where we're at. And that's that criteria I showed you before, the 41. And these are just as a reminder, it's kind of self-evident in some ways, but these are the things that affect that stream quality. Water quality we talked about a little bit. It has improved. It might continue to improve. Habitat is another big one. If you're a fisherman, you fish where the best habitat is. And these other things that all kind of interact to determine the stream quality in a particular river. A big one, again, is this connectivity. These streams evolved, or the fish evolved in an interconnected system, and once you start fragmenting it, it's not good. Fish can't get to where they want to be for the prime spawning habitat or feeding habitat, or if species are lost upstream of a dam, they can't get back. And some species like channel catfish actually migrate downstream every winter to find a deep hole where they all ball up. And so if they migrate downstream of a dam, they can't get back. So that's one of the species that wasn't actually present above the Hoffman Dam. So what's all this about dam removal? I mean, we've seen the water quality has improved. I don't know how much more it can be improved. So we have to look at some other things in order to improve the system beyond where we're at now. One is to improve the habitat, and we can do that by removing the dams. The areas behind the dams are typically poorer habitat than the free-flowing areas. And again, this interconnectivity is very important, not only to maintaining the quality, but to restoring quality after floods, droughts, and fish kills or pollution problems. So there's been dam removals all over the country. We're up to about 1,200. Fish passage works, but it's not a total connection. It's often more expensive, and it costs money to maintain any kind of like man-made rock ramp or fish ladder We've had experience with those. They take money and time to maintain. So I've mentioned a lot of this stuff, but here's kind of a review. And we have a lot of dams in northeastern Illinois. Combined with the past water quality problems, you can kind of see we have to remove the dams or put fish passage in if we want to get full restoration in some of these streams that have had historic problems. So what is the real problem with dams? We'll kind of review that real quickly. We kind of put them into two categories. There's this local effect that I mentioned in the area behind the dam. It's degraded habitat. I mean, the water is higher. It drowns out the riffles, the natural pools. There's increased sedimentation. Often you get algal blooms behind dams, so the water quality is less. So the fish, I mean, when the dam was here, did you ever see anybody fish above the dam? No, because there wasn't many fish there. And then there's a system-wide effect, and we've talked about this a couple of times now. Fragments the river, fish can't move around. So we've done a fair amount of research on these effects, and this is a typical graph that we use to demonstrate that. This is like the number of fish we catch per hour of electrofishing. And in the free-flowing areas, it's much higher than in the dammed areas. Those areas behind the dams are very unproductive for fish. And to demonstrate the system-wide effects, this is a list of species and where they occur from downstream to upstream, and kind of where we lose them at each dam. This is the DuPage River, actually, so it's not only the Des Plaines River. So you can kind of see downstream, we have a lot of species, and with each dam, we lose some, till in the upstream areas, a lot of these species aren't there. So those are the kind of two effects. So take a look at the Des Plaines River and how those dams fall out. I'm going to talk a little bit about this later, the Brandon Lock and Dam. I mean, this is a dam, but it has a lock in it, and fish can actually move through that, amazingly enough. And that's where some of the species are coming from in the Des Plaines. So anyway, this is kind of where all the dams are. A lot of you might be familiar with these. And the red ones are the ones that have been removed so far, and the yellow ones are the ones that are in place and hopefully be removed this year. And these dams have had an effect on species distribution. Some of the ones upstream are fairly small and fish can get over them at certain flows, but the Hoffman Dam was a permanent barrier. So we did a fair amount of sampling. Downstream of the dam, there was 7 samples, and we had a mean IBI of 20, our mean number of species 22, and a mean IBI of almost 30. So between the Armitage and Hoffman Dam, about the same number of samples, but only mean of 10 species. And it was a little better upstream of Armitage, but the dam did have an impact on the distribution of species in the Des Plaines. So here's kind of, I've kind of already went over this, but kind of lists them in order and when they were removed. This dam in Lake County and the Armitage Dam were removed in 2011. There's the Armitage. Hoffman and Fairbanks in 2012. These guys just went out this year. So hopefully with the DNR's dam removal program, these other dams will be removed this year. So this is really a project of national significance, that an entire river system will be free of dams. So it's something really if that happens, really remarkable. If you would have told me that 10 years ago, I wouldn't have believed it. So let's look at, you guys see this every day, so I don't have to show it to you, but just as a reference, this is the Hoffman Dam, and these are the dams that were removed in 2014. Dam number 1, it's gone, and dam number 2. We spent this project took forever, as you probably know. I think we started with John and the Hoffman Dam river rats. 1996 was it? We started talking about it. Got actually submitted in '97. So we had a long time to study it. Anyway, we did samples upstream and downstream of the dam. And so we have the number of species, for example, here in green. A little bit of variability. When the dam is removed, it shot up from 7 up to almost 30 in 1 year. Same with the IBI, shot up right after dam removal. This is the IBI downstream, and it's important to track that too. With dam removals, one of the issues is sediment behind the dam, and people are concerned about that. So we want to make sure that sediment is not having any impact on this downstream area, which is really quite good, and it didn't. There was no change in the IBI, and in fact, improved a little bit. This has been the case with every dam we've studied. When you look at the area upstream of dam versus or before and after the dam is removed, the number of species just shoots up. Oops, let's not get those yet. But here's the Hoffman Dam. Had an average of about 7 species before the removal and almost 30 after removal. And it's the same story for each one of these individual dams that we've analyzed before and after. This is even more remarkable, although this thing puts it off the chart. This is the total number of fish in the dam pool before and after removal. And here's Hoffman again. And that's, I think that's about 50 or 60, and then it goes up to almost 300. So that's a really significant increase. But this one here on the Blackberry Creek just sent it off the charts. There's about 70 fish, and it went up to almost 2,000. So it's really an increase in productivity after you remove the dam. In fact, it's the species go up average of threefold. Abundance increases 6-fold, and the IBI increases by about 40%. And that's that area above the dam after removal. So there's John holding the channel cat. We actually went up there, what was that, about 60 days after the dam was originally breached, because we wanted to see what was going on, and a fish had moved in there, and it was pretty incredible. There were hundreds of fish where we'd seen only tens of fish before, and species that we hadn't seen in the pool before, and these are listed here. And of course, we were really interested in the channel cat because it wasn't up there, and sure enough, we found one. I think John ended up netting it. And then in 2013, during the Basin survey, we found this guy, and this is one of the more significant finds that I've seen in my whole career. This is called a rosy-faced shiner, and it's one of those intolerant species. It's only found in the best quality streams that I've sampled. And we found it right out here, down below the dam, and now it always also found it upstream of the dam. And not just a couple of them. I could go out there, well, not right now, but when it warms up a little and find one for you. So it's not just a few fish. Where it came from, I don't know. I mean, it's the only other place we found it is downstream of the Brandon Lock in Hickory Creek and Jackson Creek. Nowhere else. I actually did dig up one record from 1976 up in Mill Creek. I don't have a voucher for that, so I don't really know if it's true, but anyway, it's pretty astounding. Not only that it got here, but that it can thrive here, because this is a very sensitive species. So another indicator that the water quality is improving in the Des Plaines. So. And then last year we also found a silver red horse. It kind of looks like a carp, but carp are in the minnow family, and these guys are in the sucker family, and they are a good indicator species. This is one of the rare cases where more suckers are better, and the red horse family especially we actually found one of these in 1997, but it didn't have any fins. The fins were all eroded, and that's what happens when fish are in polluted water. And it actually was half dead when we found it. But this guy, look at how good a shape he's in. So this had to actually come from the lower Des Plaines River up through the Brandon Lock. There's nowhere else it could have came from. So to me, that's pretty an amazing journey. And the fact that it's in such good shape is another indicator of good water quality. So there's been a number of those species. There he is again, and this is a river carp sucker. Again, it's in the sucker family. Probably or almost had to come from lower Des Plaines, and here's our rosy-faced shiner again. This is kind of hard to read, but it basically has a list of all the species that we found in all the basin surveys every year, and it kind of lists the new species that we found each year. So species continue to show up, and there's kind of a list of the new species we found in each survey. So there's been a total of 33 species we found since 1983 that weren't in the 1983 survey. These guys that are marked with the asterisks are ones that were found only downstream of Hoffman Dam. So anyway, where do these come from? I've kind of alluded to that a few times. This is the Brandon Lock, and this is the lower Des Plaines. And then it comes up here. This is Joliet, and then here's where the upper Des Plaines actually starts, and this goes on up to Riverside. And this is the Lockport Lock, and this is the Sanitary and Ship Canal. So I think a lot of you may know that when they built that, they straightened the Des Plaines River, that one section, I think it's called the diversion channel by some of the locals. But so where are these new species coming from? Well, they could be from refugia within the upper river. That's one possibility. Another possibility is they came from Lake Michigan down here and then swam back up. And the third, and most likely for a lot of these species, is they come up through here, the Brandon Lock. So if we look at this list again, kind of maybe do some speculation. These two species were actually found in 1983 in tributaries. So they likely came from refugia within the system, if you will. These guys that have the asterisks, most of these are larger bodied fish that would have been really hard to miss in 1983 with electrofishing. They're very vulnerable. If they're there in any numbers, you're likely to find them. So those are the ones that more than likely came up through the Brandon Lock. These guys are smaller, could have been missed, but we've done a lot of sampling, so unlikely. Some of them might have been from refuge within some of the tribs or whatever. And then the red ones are stocked, so it's hard to say they actually showed up from anywhere. So again, I don't know how they get through there. Honestly, I don't. It's a really high dam, but some of the guys that do the Asian carp work, they put a camera under there and they say the locks are loaded with fish. So I guess fish will go wherever they can.
Well, if you have a lock, when it opens, they can all go in.
Yeah. Yeah, I mean, it's imaginable, but it's just, to me, that a little minnow would go through there. I mean, yeah, it's definitely imaginable. Now, one problem is that, here's the Asian carp coming up again. There's proposals out there to actually use this point to stop the Asian carp. Like use carbon dioxide or some electricity or some method to kill the Asian carp. Well, what's that going to do to the native fish? It's going to stop them as well. So that's one thing we're really concerned about, and we voiced that concern to the Army Corps, and put all this data down in a report and let them know that we're concerned about it. So it's not something that's going to happen right away, but if we want to, this is how the Des Plaines compares to our best river, the Kankakee, and to the Fox, which is kind of intermediate. So if we want to continue seeing an improvement in this IBI, then we have to get some of these species back into the river. And a lot of them actually were here at one time. So that's why we're kind of concerned about shutting off that downstream recruitment source. So anyway, we are doing a few things on the river. We're stocking walleye, working with the Hoffman Dam river rats. Got some special regulations on this section of the river. It gets fished pretty hard. The river rats have also planted a bunch of water willow, which we've helped them with. My colleague Bob Rung, who just retired, was Mr. Water Willow. So he got him going on that. And so these guys have done quite well. So really, that's pretty much all I have to say. And I'd be glad to let you kind of read over those as we're taking questions. I assume we have plenty of time.
Yeah. What was the idea of putting the dams in the first place?
It varies. Oh, okay, sorry. He asked what was the reason for putting the dams in the first place. It varies across the whole region. On the Des Plaines, I think this one was put in by George Hoffman for recreation, as many of you know. And then some of the ones that were upstream were put in to hold water back because the river basically dried up every year. So it was, little recreational ponds or fords. On the Fox River, a lot of them were put in for hydropower because it's a little higher gradient. So those kind of went by the wayside when they put in electricity. And there's one or two flood control dams, that's very rare. One or two hydro dams, again, that's very rare. And then others that were built to build a recreational pool for boating when you have a little lower gradient, like St. Charles and Algonquin dams. So anyway, John, did you have a question?
No, I was going to say, Hoffman Dam was originally a sawmill from about 1830.
Oh, was that it?
And then it kept being upgraded and upgraded and upgraded, and finally, in 1950, they built a dam that was in the pictures.
Oh, okay.
So that
Question
was my
back
next
there?
question. The dam did not have any electrical generation purposes.
This one?
Yes, they did
I-
not or did.
I think there was wasn't there some structures in there where they tried to do it?
George Hoffman tried
Yeah.
to generate power for Hoffman Tower when he built it. Now, he was never successful, but he did try to do it.
Yeah. Yeah.
I was just at a meeting Saturday night where they were talking about what they're doing to the DePage with
Yeah.
building the habitats for the fish, deepening it, building bars, putting rocks in, and of course the water willows and the shoreline planting. Is that happening here at all or in the Des Plaines at all?
Not too much. Besides the dam removals, that's kind of the first job, and a lot of that was done because they had to dig out the thorium contamination. So they kind of put habitat back in there. So they actually had the money to do that. I mean, there are some areas where you could put habitat, but for the most part, I don't think that's the main problem with the Des Plaines. And there's a lot of habitat out there. I mean, you can't change the gradient of the river. So when you have a higher gradient, the habitat and flow is more diverse. But in the lower gradient areas, the log jams, I mean, that's probably one thing you want to do is leave the log jams. We don't want to pull those out just because they look ugly. In some cases, they might block the flow, and you need to kind of do some, especially around the bridges to remove them. But I don't think, now in the diversion channel, that's another thing. And in fact, there was a project where we put some rock bars in. I don't know if you recall that. And John actually personally built a bunch of them, rock stone by stone. So in that section, I think there might be some room for habitat improvements, and it's something you might want to look at. Yeah.
Does your organization have any input as to the order of the dam removal and what the protocols would be?
Yeah.
Steve, can you repeat the question?
Oh, yeah, sure. I'm sorry.
Some people may have difficulty hearing the question.
Yeah. Well, the last one was about adding habitat to the stream. And yours was, do we have a...
And does your organization have any input?
Yeah, do we have any input on the priority of the dams? Well, I'd like to think that I do. But it doesn't always work that way. Actually, the Governor Quinn basically initiated this dam removal program, and it was announced right out here. I don't know if you recall, but we had the new, the press was out here, and Governor Quinn was out here with the dignitaries and announced the dam removal initiative. I think that the Hoffman Dam was such a successful project that then they had the cooperation with Cook County, so they selected those dams as next. And so a lot of times with these dams, you can have your own priority in terms of which ones are best for the fish. But a lot of times it comes down to, do you have a willing, dam owner that wants to work with you, or a community that's willing to remove the dams? I mean, a lot of times we run into problems with, like on the Fox River, people don't want the dam removed, and there was some resistance here, in fact. So it's not only a biological thing, but surprise, there's politics involved. Yeah, I don't know who was next.
Question, what about the normal or natural spawning of the species? Let's use one species, walleyes.
Mm-hmm.
Walleyes go on the basis of water temperature.
Yeah.
And as an example, you could use something like, let's say, Wisconsin River, Petenwell Dam, so on and so forth. I fished that quite a bit, and there's a tremendous movement of the walleyes at a certain time of the year, certain temperatures, up to these dams. Now you pull all these dams out of here. What happens now?
Did you guys hear that? Okay, yeah. He asked about basically the spawning behavior of walleye. And on the Wisconsin River, they move upstream until they hit a dam. And if we remove all these dams, will the walleye continue moving up and out of the range of fishing, I assume you mean, for fishermen down here? Walleye do move, but they also, when they find suitable habitat, they will stay. I mean, they're not every walleye will move all the way up to the highest dam in the watershed. So, and especially in the Des Plaines, where there's not a whole lot of really good walleye spawning habitat upstream of here. They like, fast flowing water. So there will be some of that going on. And you hear that from the fishermen, but we went down, after the dam was removed, we were here last year, and we caught, 13 or 15 walleye right here. So this is good habitat, and the walleye will use that habitat. I mean, they might move out for a while, but they're going to move back in. So it's a little bit of a trade-off, but bottom line is, if there's good habitat, find the fish there. Yeah.
I know I can't say these two words in Florida, but in terms of climate change, do you think that areas that have had dams removed, that the fish will be able to adjust more to changes that will be occurring?
Yeah, actually, she asked about climate change and how dams will help fish deal with that, basically, or if it will. And yes, it will. Actually, that is a concern among the fisheries biologists. And an example on the Fox River in 2012, when we had low water and really high temperatures, we were actually starting to lose fish. And in fact, even on the Des Plaines River, we lost some of the cool water species. There was some dead muskie out here and pike. But on the Fox River, we actually lost some of the suckers as well, including greater red horse, which is a very quite rare species. So there are these fish that can't tolerate the heat, and along with that comes lower dissolved oxygen. When the water temperature goes up, the oxygen goes down. So it just increases the chance that fish will be extirpated from an area. That means basically they become locally extinct. So the global warming could exacerbate that, where you find more local extirpations due to low DO, low flows, high temperatures. If it occurs upstream of a dam, then you've lost that species. So by having things more interconnected, rivers can handle that. I mean, they do. Natural drought, floods, there are local extirpations, but the fish can move back in there as long as everything's connected. So it's a good question.
Could you also summarize it, without the dams, you give the fish more flexibility to survive?
Yeah. Yeah, he basically rephrased it. It gives them more flexibility to survive and more resilience is what we're looking for. Oh, where? Oh, sorry. Right in front of me.
Some of your visuals actually indicate you had found muscadines right out here, muskies.
Yeah, he asked if about the muskie that were on the list. Yeah, we actually have found them upstream of the dam, right in the Salt Creek bypass structure. And I know I've gotten a few pictures from fishermen that have actually caught them hook and line here, so they do show up. Species like that, and this gets back to the question this gentleman asked about spawning. Muskie don't naturally occur in Illinois really, and they don't spawn. So they get stocked in various lakes and other water bodies, and they kind of get out of there over the dams and show up in the rivers. Walleye have a really difficult time spawning in Illinois, and so all of our major rivers we actually stock with walleye, the fox, the kankakee, the rock. So those are the only species we really stock. And in the Des Plaines, we chose to stock sauger because they're a little hardier. We thought they might do a little better with the changing water levels. So anyway.
I was just going to ask on the depth of the river around here, like you took us from maybe the scout cabin over down into past the dam, where the dam was.
Mm-hmm.
It looks very shallow most of the year. Is it like a foot deep or 3 feet deep? And could you get a canoe, mostly on board, could you get a canoe through the dam area? Is there like a channel down the middle, or is it just shallow and you'd have to wade it?
There is a channel upstream of the dam. I think it might have even been excavated by some stories. They excavated the bedrock. And then the design of the dam was supposed to be kind of a V shape, so it encouraged the flow to go toward the middle in lower flow. So I would hope you could get a canoe down through there. I haven't tried it yet, but rivers, the water's going to fluctuate in a low flow. It could be inches rather than feet. That's just natural fluctuation. And I don't think I repeated that question. It's about whether a canoe could get through there. Yeah.
I don't know how you would describe, if you could, what the natural state of the Des Plaines is in this area, but is it the way it is more or less currently, low and slow? Is that more or less the natural state? Or am I just noticing that it looks that way because the dam is...
Well,
such a thing as a natural state for a river in any particular area.
yeah, did everybody hear that?
No.
Oh, okay. To summarize,
I'm not sure what I'm asking, so...
Well, I think I know what you're getting at. You know, what is the natural state of the river, and how did the dam influence that in terms of the flows? Well, obviously the water is lower now because the dam's gone, at least upstream of the dam. That shouldn't have any impact on the downstream area. And whatever water was coming over the dam is still coming through where the dam isn't anymore, if you follow me. I mean, that was one of the concerns that people had. It's like, you take the dam out, the river's going to dry up. Well, it used to dry up. And getting back to your question about the natural condition, I mean, there's so many wastewater treatment plants discharging into the river now that it's not going to dry up. And we're not going to probably ever return to the natural condition, which is, you know, a dry riverbed every summer. So I don't know if that answers your question, but that's kind of the situation we have. Yeah?
Getting at that, with the question of like the effluent that's being dumped into rivers and different points. And I see your data is looking only at the biodiversity present from fish. Is there also water quality sampling that you can layer together to say both the water quality supports the fact that we're seeing this, or the fish species supports the fact that we're seeing increased water quality? And then as community members, you know, are we seeing increased non-point source of pollutant matter getting in, which we be doing? Those kind of line of thought, sorry.
Okay. I'm not sure I can repeat that. No, actually, she asked if there is water quality monitoring going on, and if it actually substantiates some of our observations with the biota, with the fish, and if there's more actually non-point source pollution, which is runoff. Basically, it's not coming out of a pipe, it's coming from everywhere. To the first question, yeah, I mean, the basin surveys are done in cooperation with Illinois EPA, and they do water quality sampling not only every 5 years, but they have what's called ambient stations that they sample on a routine basis, I think yearly, in fact. And I've looked at some of that data, and I haven't seen the data from 2013, but of course, from 83 to 97, there was a big improvement. From 97 to 2008, I didn't notice any really change. And I've just recently started really digging into this data to realize that 2013 was better. I mean, it seemed a little better when we're out here, so I haven't seen the 2013 data. So that's a good question and something that I will definitely be looking at. As far as non-point source pollution, I don't know. I mean, certainly since '83, we've probably had more development. Is that possible in the upper areas? So you get more runoff. Urbanization itself is very hard on streams, and that happens at a very low urban coverage. Like when you get up to like 10% impervious surface, you know, surface the rain can't go into, you start seeing degradation already at that low percentage. So it's possible that runoff has increased. One of the problems is nutrients, and the wastewater treatment plants don't remove nutrients. There's no nutrient standard in Illinois currently, so like phosphorus and nitrogen just go right through the system, and they encourage algal growth. And too much algae is not good for the system because they produce oxygen during the day, like any plant, which adds to the oxygen, but at night they respire, they breathe, so they take up the oxygen. So a lot of times you get a sag in DO when you have really highly nutrified river systems. And the dams exacerbate that because they slow the flow down. But all very good questions, and I don't think I answered any of them. Yeah, way in back.
If the amount of water moving through the river where the dam was is the same, has there been any effect on flooding locally or upstream?
I'm not sure about that. I was talking to Lois before the talk, and she lives upstream. She said she wasn't sure if she noticed it or not. The engineers told us it would have no impact on flooding. Some of us were skeptical about that. I mean, you're lowering the water level 12 feet. You would think it has to have some impact. But remember, there's gradient there. So even though you lowered it here, it only impacts a certain distance upstream. And then they also say at higher flows, the dam kind of disappears because the water's flowing faster, it gets compressed. I mean, they have these models that tell you all this stuff. You guys tell me.
We haven't had a 100-year or 1,000-year flooding since the dam was removed.
Oh.
We have a 100-year flood about 4 or 5 times a century, which makes this statistic. We have had pretty much.
So,
We have had a flood.
have you noticed any difference?
The water was cleaner in the last flood.
You mean the water in your basement was cleaner? John, do you have a comment?
In regards to that, I'm Hoffman Dam river rats for anybody that doesn't know me, okay?
Everybody knows you, John.
Yeah, I'm afraid of that. But anyway, I talked to some of the people that live on West Avenue, and they say that in 2008, they had a water level that was at a point. Now, we had a bigger rain in 2013. The 2013 one is the one that flooded Forest U because it went over the dike in Ottawa Trail Woods. They say on West Avenue that between 2008 and 2013, they were about the same place. So there may have been some flood benefit to it. Now, being the fact that we're planting up there last year and 2 years ago, and we're going to be doing it again this year, what we're seeing is the river channel is widening out because we're getting rid of all the sediment that was on the banks that the dam was building up there. So we're actually getting a wider river channel up through the West Avenue and Maplewood area. All right? The river goes narrower at low water, but at flood water it's actually widening out the channel. So there may be some flood benefit.
Yeah.
The zero is kind of, I'm very skeptical about that myself. Now the thing you have to remember, when Hoffman Dam was initially cut in 2012, the water level went down all the way to Riverside Golf Club. All right? When you got through Riverside Golf Club, there was no noticeable change in the water level.
So how far upstream is that for
Well,
people that don't know?
what, 2.5 miles maybe, or something like that, 3 miles?
That's
26th Street.
But it went down about 5 inches at 26th Street immediately. At Cermak Road, you couldn't detect anything.
Any other questions?
We'll take one more question.
Who is responsible or on the point of solving the Asian carp problem?
That is a multi-jurisdictional, multi-agency effort. We're actually getting money from the federal government, and we have a staff of, I think, about 15 people working on it. There's 6 biologists at my office location that are working on it full time. So it's a big deal. And then other states and the U.S. Fish and Wildlife Service is involved, the USGS. All the universities are getting money to study various aspects of the life histories and biology and ways to control them and even sample them. I mean, so it's a big effort.
Hopefully you'll be able to stay around and take questions from
I could stick
individuals.
around for a few minutes.
Okay. And I want to thank you for speaking tonight, Steve.
Thanks for having me. Really good questions.